Hello and welcome back. These will be the video notes for 10.1, graphing in the form of y equals ax squared plus c. And you'll notice there's no middle term here. There is a PDF available if you'd like to follow along. First thing is, what is a quadratic function? It's simply a non-linear function, meaning it's not a straight line, that can be written in the standard form of ax squared plus bx plus c. However, for this video, we are not going to include the middle term. We'll see that in another video. Another important thing is this a right here cannot equal 0. If it does, it's not quadratic anymore. The graph of a quadratic function creates something called a parabola. And a parabola is a U-shaped graph that you see right here. And it has a couple of key characteristics. First thing is it's got this point at the bottom here called a vertex. That's where the graph changes direction. And another key characteristic here is this line right here in the middle called the axis of symmetry, and you'll notice that points on one side of the line, let's say a point right here, is the same distance from that line of symmetry in the middle. That means if we graph points on one side like this, all we got to do is reflect those points across the line of symmetry, and then I can sketch my graph. And that's really what we're going to talk about here, is the characteristics of a parabola using ax squared plus c, and then how can we graph them. When you're graphing ax squared, there's no c value, just an ax squared. You've got the a out in front, that's the coefficient, the leading coefficient. When that a value gets larger, or when the leading coefficient gets larger, the graph becomes more narrow. Now when that a value gets smaller, or the leading coefficient gets smaller, the graph opens up a little bit wider. And we're going to take a look at those graphs now. Okay, so what we're looking at here, we have what's known as the parent function. And what we get is this nice shape here where the vertex is at 0, 0, located right on the origin. And it's open upwards. So what we're going to do is we're going to leave that one there. And we're going to make the a value. Right now the a value up front here was a 1. I don't have to put it there. But if you see, if I put it in there, it does not change the graph. If I make that a little bit bigger, let's say I make it 4x, and then I square it like this, you can see that the graph then becomes much more narrow. And if I make that a little bit bigger, let's say instead of 4x I make it 10, it becomes even more narrow than it did before. Now if I make that leading coefficient become smaller, like a fractional value, but it's not an improper fraction, let's say 1/2, 1 over 2, you can see this blue one here is wider than the original parent function. And let's say I put a 5 under there instead, 1/5, it becomes even wider. And if I want to really make it wide, I can put a 1/20 and really make that graph open up. But you'll notice that the vertex does not change. So this number out in front, this leading coefficient, it has the purpose of opening the graph wider or narrower. And we're going to find out here in a moment, it also has another purpose. Another thing about graphing just the ax squared, if the a value, which is the leading coefficient, is positive, so this number right here is positive, the parabola will open upward, kind of like this, creating a minimum value, which is located at the vertex. It's the lowest point on the graph. If the a value is negative, then the parabola will open downwards, like this, creating a maximum value, also found at the vertex, but the vertex in this case ends up being at the highest point of the curve, and that would be called the maximum. Now here's an important one here. The minimum and the maximum of a quadratic is the y-coordinate of the vertex. It is not the x-coordinate. The vertex will have an x and a y value for it because it's a point on the graph, but the min or the max is simply the output, the y-coordinate, the range value at the vertex. Okay, so looking back at our parent function here, we have 1x squared. And we can see that it's positive, so the graph opens upwards like this, and that the lowest point of our graph here is 0. So that is a minimum, and the minimum of this function is 0. If I were to put a -1 out in front, you'll see that the graph actually turns upside down, creating a U shape that opens downwards. And now we have a curve that has a high point, creating a maximum. So that 0, 0 is the same as it was before, only now we say it's the biggest value the function can produce and not the smallest. That's the difference between a min and max. Okay, so now how do we graph? We did say we were going to have an ax squared plus c, and the only thing that's going to be changed is now we have a constant value at the end. So this c value at the end of our equation is actually going to represent the y-intercept of the parabola. You'll see as we change the equation, all that number represents is where the line is going to cross the y-axis. Now let's suppose we take the graph of x squared minus 5. How do we graph it? Well, this is our domain side and this is our range side. So we pick our domain. That's our input value. That's our independent value. So we input a 0. So 0 squared minus 5 is now going to equal the y value. So 0 squared is 0. 0 minus 5 outputs a negative 5. And then we can input a 2. And then 2 squared is going to equal y. So 2 squared is 4. 4 minus 5 is going to give us a negative 1. And we can do the same thing with a negative 2 squared minus 5. But a negative times a negative is still going to give us a 4 minus 5. That outputs a negative 1 also. Input a 3. 3 squared minus 5. That would be 9. 9 minus 5 is 4. And if I input a negative 3, that's going to be the same thing as a positive 3 squared. That would be 9 minus 5, and that's going to be an output of a 4 also. So now what we're going to do is go in and graph these points. I've got 1, 2, 3. I've got 5 points on there. And what we're also going to do is determine what is the domain and range of the function. Keep in mind that the domain is all the possible x values that the graph can produce, and the range is all possible y values that the graph can produce. And then we'll take a look and see what the min or max of the function is. Okay, so here we have our equation graphed out. X squared minus 5, there's our equation right here at the top. If we input our 0, we can see that there is a 0, negative 5, and that's actually producing this point down here. Let me just change that a little bit thicker. And if we go ahead and input our other values, which were 2 outputs a negative 1, so there's our other value. And if I input a negative 2, that outputs a negative 1 also. And you'll notice that the y-axis actually acts as our axis of symmetry. Notice how this point, negative 2, negative 1, is 2 units away from this line, and the point 2, negative 1 is also 2 units away on the opposite side. That's what we call symmetry. Let's go ahead and put the other ones in. We got a 3 and a 4, which produces the point up here, and a negative 3 and a 4, which produces the point up here. Now, if you were trying to graph this by hand, you'd just put those 5 points on there, and then you grab your pencil or whatever it is you're using and try to eyeball a little curve that goes through the points. And it doesn't have to be perfect. All right, so the domain and range. Domain is all of my x values that could possibly be used. That's going left and right. You'll notice these lines have arrowheads at the top. So that means we're going to eventually go infinitely out to the right. So the domain on here is going to equal all real numbers. So any number for x can be used in positive or negative. However, the range is a little different. We see that this is a minimum value function. There's a couple things that tell us. The leading coefficient over here was a positive, and we can also see that it opens upwards. So the lowest point that this graph will ever reach is a negative 5. All other y values are going to be bigger than that. So we would say that we want to have y values that are greater than or equal to negative 5. So our range would be all y's greater than or equal to negative 5. The y values will never go lower than negative 5 because as they come down like this, they change directions, go back up, and that's why we say that the negative 5 is actually the minimum. The y-coordinate of the vertex is the min or the max. In this case, it's the minimum. So we'll never have an output that is smaller than negative 5. For example 1, we've got actually 3 parts, A, B, and C, and the question is, what is the domain and range of the function? I'm going to alter this a little bit and say, what is the min or max of the function as well? Okay, so here we go. We've gone ahead and used a graphing calculator to graph this for us. It's a little bit more accurate. We see we have the equation 1/2 x squared plus 2, and our y-intercept, remember this is the y-axis here, our y-intercept here is at positive 2 as expected in this equation. We also see that the leading coefficient was a half, which means it should be wider than the parent function. Okay, so the first thing is, what is the minimum value? Well, the minimum value is the y-coordinate of the vertex. Well, the vertex is located at 0, 2. This is the y-coordinate, so the minimum value is positive 2. What is the domain and range? Well, unless a scenario like a word problem limits the input value, which is your domain or your x values, your domain is almost always going to be, in a parabolic scenario, all real numbers. So any value for x and y. We do have some limits, and we'll show you an example for that. The range, though, has a minimum. So the range has to start at positive 2, but can go upwards infinitely. So y values would have to be greater than or equal to positive 2. Example 1b, we still want to know what is the domain and range. We're going to go ahead and state what the min or max is also. So here's the graph. Again, we've used the graphing calculator. The y-intercept is a positive 4, and we can see, yes, it crosses right here at positive 4. That vertex is located at 0, 4, and we said this is a maximum value because it opens downwards like this. So the maximum of this function will be a positive 4. Remember, it's always the y-coordinate of the vertex, never the x. The domain, as we said, is almost always all real numbers, and that's just a little abbreviation for all real numbers. But the range values are my y values. We said there is a maximum here. The maximum y value is a 4, which is at the vertex. But all of our other y values for our dots go downwards. So we're looking for all y's that are less than or equal to positive 4. Example 1c, what is the domain and range of the function y equals 1/20 x squared minus 8? And here's the graph, and we can see that, yes, it does go through a y-intercept of negative 8 as expected. And the coordinates to that vertex, which is the lowest point, is 0, negative 8. This is the y value of the vertex. So our minimum value, because it is open and upwards, minimum is negative 8. Our domain, again, is going to be all real numbers until otherwise stated. And the range value here, well, we have a minimum of negative 8. So all of our y values along this curve are going to be higher than that. So our y values are going to be greater than or equal to negative 8. And some of you might start noticing that our minimum or maximum value kind of coincides with the upper or lower limit of our range values when trying to determine that. Example 2, the graph of the function y equals 0.09 x squared models the cross section of the reflective surface where x and y are measured in meters. So this appears to be some sort of reflective mirror or maybe a radio antenna. We want to use the graph to find the domain and range of the function in this situation. Okay, one thing you'll notice is that this is a piece of metal here that does not go infinitely up. So there's no arrowheads at the end. It kind of just stops. So we know that there's not going to be a infinite amount of domain. So come right here on our x coordinates and we'll see what those numbers are. This appears to be 5 over here and a 1, 2, 3, 4. This looks at negative 5. So the domain values are, domain is going to be all x's greater than or equal to negative 5, but less than or equal to positive 5. So if we want to know how wide that antenna is, or that reflective mirror, we can say it's 10 meters across. But we can describe the domain as all x's greater than or equal to negative 5, but less than or equal to positive 5. The range value, now the range value, we're talking about the reflective surface, which is in the inside here. And the reflective surface starts at 0, and range are my y values. So I want to go, how high does this go up to? And we can see that the range starts at 0. So let me go ahead and put that in. Range starts at 0, but it's greater than or equal to, and range values are the y values, and less than or equal to. Now, you could probably try to eyeball that and say that looks like about 2.25, but we have an equation here. So what we're going to do is we're going to use our calculator and crunch a number to figure out what the actual range is. We know the range occurs at this point right here on both sides, and it's the same height on both sides. And we'll also notice that looking down below, we have an input value of either 5 or negative 5, and they'll both produce the same height of that graph. So all we got to do is go back to our equation, y equals 0.09, and in place of x, put in our 5 meters squared, and just output the y value. So go ahead and use your calculator. So we're going to have 0.09 times 5, and that's going to be actually, coincidentally, 2.25. So we kind of got it right. So if you're taking a test, you would probably not want to eyeball that. You probably want to take your input value right here, put it into the equation to calculate what that height value is along the curve.